Chapter 4, Section 4, Irrational Numbers, Apprentice Level. All right, before I actually get into these exercises here, I'm just going to talk about briefly what an irrational number is. Okay? In short, an irrational number is a number that if you try to write it out, the decimal will go on forever. Okay? It will never end. And on top of that, it will never repeat. Okay? So it will seem to you like the digits are random. So an example would be pi. Okay? Pi is an irrational number. Okay? It's 3.14159 blah blah blah. It goes on and on and on and on. Also, if you try to take the square root, of any number that is not a perfect square, so for example 7, okay, that is an irrational number as well. If you put it in your calculator, you will get 2.64557, and so on and so on and so on. Eventually your calculator will have to cut it off because it can't hold any more, but these numbers go on forever. Okay. But these numbers down here, actually none of them are irrational, but that's okay. Okay. So here it says powers as radicals. What's a radical? A radical is when you have a root symbol. Okay? That's what it means in a nutshell. So 4 to the power of 1/2. Okay, well we've worked that one out before. It's 2. Okay, and the square root of 4, okay, that's also 2. Okay, so what it means is 4 to the 1/2 can also be written as the square root of 4. So 9 to the 1/2 is 3. The square root of 9 is 3. 16 to the power of 1/2, it's 4. Again, why is it 4? Okay, it's just a quick review. Remember, 16 is a perfect square. So I can write that as 4 to the 2, and this is still raised to the 1/2. Okay? But you know from your exponent laws that now we can multiply these exponents together. So 2 times 1/2 is just 1. So I don't even need to write it. It's just 4 to the 1, or 4, okay? Which is the same thing you get when you take the square root of 16. So in general, x to the power of 1/2 can be understood as the square root of x. Okay? This is a power. Okay? This is a radical. Okay? And the number specifically that's underneath this square root, just a bit of lingo here, that's called the radicand. Okay. There's something called an index, but we'll get to that in just a second. 8 to the power of 1/3. Okay. Well, something to the power of 1/2, that's the same as a square root. So it seems logical that something to the power of 1/3 is a cube root. Well, let's test that. I know that 8 is indeed a perfect cube. Hence, I can write it as 2 to the power of 3. Remember, you should memorize your basic perfect cubes. And that, of course, is still being raised to the 1/3. So if I apply my exponent rules now, I multiply 3 times 1/3. 3's cancel, and I'm left with 2 to the 1, or just 2. Okay. Well, the cube root of 8 is 2. Okay. So this shows that something to the power of 1/3 is exactly the same as taking the cube root of that something. So 27 to the 1/3, or a cube root, that is 3. Because the cube root of 27 is 3. What is 64 to the power of 1/3? Well, that's equivalent to saying, what's the cube root of 64? That's 4. Because 4 times 4 is 16, times 4 one more time, 64. Okay. So just generalizing, if I have some number x to the power of 1/3, that's exactly the same as saying the cube root of x. Okay, and again, this is a power, just like here. This is a radical, just like this one. The x inside is called the radicand, but notice how I had to put this little number here to tell us that it's a cube root and not a square root. That's called the index. So if you see a root symbol and there's no number in here, we're assuming it's a square root. In fact, it's not wrong to put a little 2 in there, okay? But on an exam or in a textbook, the 2 will never be written there, but it's technically there, it's invisible. But if you need something other than the 2, you have to write it in. So the 3 is a little index. Next, we want to express all variables with fractional exponents as a radical. Okay, so I have y to the power of 1/2. Okay, well, that's the same as saying the square root of y. Okay, so this is a power. This is now in radical form. Y itself is the radicand. Okay, xy to the power of 1/2. Okay, well, everything here is being raised to the power of 1/2, which means that's the same as saying take the square root of everything. Okay, but because everything is underneath this square root symbol, I don't need the brackets anymore, as long as they're both under there. Okay. All right. This next one looks very similar, but notice there are no brackets. So therefore, this 1/2 is only affecting the y. This x has nothing to do with it. So I can't really write this x as a radical, only this piece. So I still have x, and this is times the square root of y. Next, y to the 1/3. Okay, well, this number here in the bottom, we know that that has to be the index. So that's the cube root of y. Okay, these mean exactly the same thing. Xy to the power of 1/3. Okay, again, everything is being affected. So everything goes under that root. I don't need the brackets anymore. Okay. This, however, just like the previous example, only the y is being raised to the power of 1/3. So only that can be written as a radical. So this becomes x times little 3. That's the cube root of y. And there we are. Okay, y to the power of negative 1/4. Well, by convention, okay, we don't want this little index here, in this case 4, to be negative. So before we convert this to a radical, we want to make this exponent positive, and we already know how to do that. It becomes 1 over y to the 1/4. Now we can write this as a radical. Okay, so if this was 1/3, it would be the cube root of y, but this is 1/4. So we put our index here, and we call this the 4th root of y. Okay. And there we go. Next one, xy, and everything is being raised to the negative 1/4. So that is 1 over xy to the 1/4. And now this part here I can write as a radical. Everything is being affected by this 1/4. So this is 1 over the 4th root of x and y together. So they both go under there. Okay. This next one you have to be careful. Okay, there are no brackets, so this x here is not connected to this exponent. So the x is going to stay in the numerator. Okay. But this y can go in the denominator, and that becomes positive 1/4. So writing it as a radical, the x stays as is, and this becomes the 4th root of y. Not too bad. So to generalize, if I have some number x to the power of 1 over n, again, n could be 2, could be 3, could be 4. Okay, so those are the examples that we've worked with so far, 2, 3, and 4. writing it as a radical looks like this. The nth root of x. Okay? And again, if n is 2, okay, we don't need to write the little index here. We just leave it blank and we assume it's 2. But if n is any number other than 2, we have to put it in. So power, radical.